So, good afternoon, and welcome to the real-world NoSQL schema design session. And let me start with first a quick introduction about myself. So, I am Tug, and I'm working at MapR as a technical evangelist. So, my role is to help communities, developers, users of the platform or any other big data project to understand and define project architectures. And as you can see from my background, I'm coming from the database and NoSQL database before joining MapR last year. And as part of this experience working with NoSQL and now Hadoop at the top of MapR, I choose to propose this presentation about NoSQL in real world, and I will today discuss about some ideas about schemas and NoSQL databases in the context of your big data platform. So when we talk about database schema, if you look at your relational database, we are used to create this kind of entity relation diagram where we build a logical view of the database based on the third normal form and so on, where we can easily build a proper schema, at least for relational databases. And it's very easy to switch from this logical view into a physical view of the database, meeting entities to tables, attributes to columns. So far, it's very easy. Then you talk about relationships with foreign keys, and many-to-many is relationship with junction table. But one of the challenges for that, and it's working very, very, very well with relational database, and we don't have to abandon relational database for many cases, it's working perfectly. But what we see is more and more information are coming in a non-structured way that you cannot necessarily use and store easily into a relational database. For many reasons, because the volume is too big, so scalability issue, and high availability because you want to build real-time applications that needs to be 24/7 all over the world with multi-master write on different data center. But also, and more importantly, in my opinion, it's because you want flexibility in the schema. You want to be able to adapt quickly to change. Suppose you are working on an IoT application. The messages sent by a specific sensor on a specific version could change quickly, and you may have different sensors sending different set of attributes. It's a very complex thing to do in a relational database. It's a very easy thing to do into a NoSQL database. So for all these reasons, when we talk about big data, Hadoop, we have different ways of storing the information. One way will be to use a file system and the distributed file system like HDFS or MapRFS, or the other way will be to use a NoSQL database, HBase or MapRDB. And today I will focus obviously on the NoSQL part, but how do you choose? It really depends on how you want to access the data. How do you want to process the data? So if we look at the file system itself, the data store of files. It is very efficient to store a very large amount of data, but it's very, very efficient when you have to do large scans over a very large volume of data. So when you do process to read all the data, doing some aggregations, machine learning, the file system is a great solution. But it's not very efficient when you want to do random access to a specific line into the file, or if you want to do a specific update into a file. On HDFS, it's almost impossible to make that in an efficient way. Change one byte into a file. In MapRFS as a file system, you can, if you want, open any file of any size and update it, but it will still be less performant and less efficient than using a NoSQL engine. So in the Hadoop and MapR ecosystem, you have the choice of using HBase and MapRDB that will organize the data as rows and documents. And what is great about that, it's very fast to access. So you have a raw key, you have a unique ID for a specific entry. And you can, even if you have a very, very large table with multiple terabytes divided and partitioned on many servers, it will be very fast to access this specific document or this specific row and update a single field or return a subset of the field. So every time you will have random access, think about the database. But in this case, you want to be able to store the data in an efficient way for the applications and for the IOs and so on. So this is where we are thinking about or talking about the schema design. So if you look at the relational database, you have rows containing fields and field containing specific type. But the structure of a table is fixed. All the rows have the same structure. You cannot have, in an easy way, have one row with 5 fields, another row with 20 fields, if you didn't define this 20 field before. But you have some interesting part. Its structure is predefined. At the end, it's also interesting because you can validate some constraints. So it's positive, but in the same time, it's negative depending on the use case. And you may have referential integrity depending on how you want to develop. And sometimes on a very large and old database, if you look at it, think about what you have in production today, think about ERPs and all this stuff. Many cases, the foreign keys are not activated anymore because it's complex to maintain over time. It's complex to maintain, especially when you have to update schemas. So the expression is very easy over the set of rows, but also what is nice is you know the schema, you can describe the schema. So this is specific to the relational. When we talk about HBase and MapRDB, and MapRDB use exactly the same API as HBase, except the implementation is using MapRFS instead of using HDFS. So for the developer, when I say HBase or MapRDB, think about it's exactly the same thing for you. So the rows contain fields, same as a relational database, but the fields are bytes, so they are not typed. You save whatever you want with the size that you want, but the structure is flexible. So you can add, modify, and remove specific attributes on the fly depending on what you want to do with your application. And I will give you some example later. So you have no predefined structure. So it gives you this flexibility of evolving over time or modifying the data, the structure of the data inside your application when you do processing of the data. And you have a single key. And this is a very important part about how you want to scale on your access to information. The most efficient way in any databases, NoSQL or relational, is to use the primary key to access the information. In the context of HBase and MapRDB, you have one single key, that is a raw key or the ID. So think about it when you are designing your applications. This is used to fast access, but it's also used for distributing the data over the set of nodes of your cluster. So to avoid a specific hot access and having too many applications or too many activity on one single node, when you have a large cluster and lot of activity, think about the keys. And inside HBase on MapRDB, you have interesting feature like timestamp and versioning of specific field, but also column families to optimize access on disk and the way you organize. So everything in HBase and MapRDB has been pushed to about performance in throughput, read, and very fast access to the data when you want to read, when you want to update. You have many options in the way you want to organize the data. And I will take some example. How do you work around the fact that you have the lack of flexibility in the relational world? Many cases, people are storing XML, JSON, or string into a large blob just to make some access or store more complex data. You can do exactly the same in HBase. In this case, you will mix kind of the models inside a row where you will store complex objects in specific field value. Remember that inside HBase, everything is bytes. We don't care about how you want to organize the information. But in this case, when you have complex data type into a single attribute, you have to bind that to your application on the read. And you can obviously, even if you don't have referential integrity using foreign keys and constraints, you can still do using this kind of embedded object, a view that is more or less a join between different documents, between different information, and you will see some example. And the list of objects could be a list of values that you reference another table, except that the constraints, it's not pushed and validated by the database. And you have many reasons for that. performance and scalability. When you have to control many things between different physical servers, it's costly. Think about why are you using Hadoop? Why are you using a big data platform? It's because you want to scale out. You know that you will have multiple machines, so you don't want to have processes dealing with join between tables, between servers, or constraints on transactions between servers. This is why into NoSQL databases like HBase on MapRDB, you don't have foreign keys and you don't have multi-row transactions for performance and scalability. So let's see how you want to design the information into HBase. So you have different ways. Either you look at the data from a raw view or from a column view, depending on how you want to access this information. In both cases, it's very performant, it's very efficient. For example, the way you will represent the information into this sub-element when you have to deal with complex data, either you do a single row with different value. You see column 1, value 1, column 1, value 2, and so on. So you can parse row by row and be very efficient. Or if you want to make it efficient in the way you traverse the rows instead of the columns, you will choose to go with one single column. I will get all the values. In both cases, depending on how you want to process the data, you will organize the information. And one very important part when you design your applications, your database schema, you have to think about how the applications, how the process will deal with the data. If we step back and we look at the relational database, when you design a proper third normal form schema, it has nothing to do with the application. You don't even think about the application. You just say, it is a correct format because I don't repeat some flow, I don't repeat some field, I have not denormalized on everything. But think about the price you have to pay if you want to get some data and your application is doing 99% of the time reads. You will have to do join all the time, all the time, all the time. This is why people in data warehouses have a different way of organizing the information. So in your edge-based application, it's the same. Think about how you want to access the information from your application, from your process. And I can take an example with a time series database. When you want to work with time series, you need two things. You need to be able to save lot of information and do that in a very efficient way. Think about hundreds of sensors in a factory that will send messages every 10 milliseconds. So first you have to be very efficient when you save the data, but you also have to be very efficient when you store the data. You want to reduce the size of the data and make it very efficient for the other part of the application that is not the ingestion, that is about the analytics part. Because most of the time when you work at the time series, it's about reading the data, doing some aggregations, doing some analytics. So what is nice about having a database like HBase is the column names could be used as application information. And if you are familiar with a relational database, a column name defines a specific value. In this case, the column names can define not only the value, but the context in which this value has been saved, give you a lot of flexibility in what information you want to save. So time offset in the time series, I will give you this example, but it could be the top level domain, so the name of the website or the page, and then for each column, each value, you will have the number of clicks and so on a single row, or you have a vendor IDs and some information about the profile. So if you want this flexibility about having multiple informations on a single row, you cannot do that with a predefined schema. So what you will do is you look at how you save time series database if you are inside a relational database. What you will do is for the time series ID, it could be your device. At a specific time, you will store the value. As I said, let's say you have 1,000 devices, each device sending a message every 10 milliseconds. See the number of rows you will have to create, huge number of rows. And accessing the information just to calculate a specific time give me all the statistics between 3 p.m. and 4 p.m., you will have to scan a big, big number of rows. So using a NoSQL database like HBase, you can reorganize the data, moving some of this value into a single row, this way. So what you will have the same. You will have the device, but on the line you will take a specific time window. In this case, it's a minute, but it could be an hour, it could be 10 seconds, depending on how the device are injecting information. And each of the column will be the information about when it is a time offset compared to the start time. And as you see, in one single row, now I can store many informations. Look at this one. At 52 plus 4 seconds, plus sets, sorry, mixing French and English is bad. At 7 seconds, I have a 4 value. At 11 seconds, I have 8 value. So you can make it very, very efficient in terms of storage. And if you know the API in HBase, it's just a single put. So you just say for this specific key, because the row key now, it's a mix of two things, the device and the time. As I mentioned before, inside HBase, you have one single key. This is a row key. So you have to be smart about the way you want to organize the information. And why did I choose to use this with the device plus the time? It's because think about how do you want to work most of the time with this application. Most of the time, what is important is you want to know how this specific device is working. If you are on a Formula One, you want to see how was the specific part of the engine working. So you will have the car, the device, and the time. Because it's very efficient to scan this 101. Even if you have 1,000 or 1 million records, you will only start with this. Then you will have the subset into the time window to give you a very efficient way to scan the data. Why do you want to scan the data? It's to do analytics. You want an average of this specific value. What you can do, especially in time series, I think we all agree that when you are in 3 p.m. 52, the 3 p.m. 51 data will never change, I hope, or you will become millionaire with a time machine. So what you do, you can start to do aggregations inside your database. So in this case, you will have processes that will take the data and replace the core value in more efficient storage, where you can kind of mix the value. In this case, I just use one single column as a compressed view, but you can also do some aggregation directly. For example, every hour, you will just read this device, create a new row with many information about averages on different values. This is something where very often we use Spark to run this kind of job. On a regular basis, you will read a subset of the information. So this is the case for a time series database. Let's take a different application with a more general data set. A music application. So maybe you know MusicBrainz. MusicBrainz is an open source database for music, artists, albums, and recording, and so on. So think about it as a product catalog. So you have how it's organized today. It's based in a relational database, and you have many information. But because of the relational way of organizing the data, when you talk about one artist, it has 7 tables. Because he has the names, the dates, the aliases, the categories, and so on. Think about as an artist, as a band, for example. You may have many information about the people in the band, and so on. And in fact, you even have more databases than just the artist. You may have also some information about hashtag, rating tables from the users, and so on and so on. So you will have this kind of schema. And sometimes when we discuss about NoSQL into the companies, people are saying, NoSQL is hard to use because you have no schema. I don't know what you have. Here, it's okay, but add 180 tables to this. It's not because you have schema that it's easy to read. And think about what you have, these 20,000 tables in SAP. Schema or not, you are not smart enough to read everything. So it's more about how do you organize the data, think about your application, how it will be efficient, even if you cannot do this kind of schemas. From an application point of view, these logical schemas could be interesting independently of how you organize the information. So we have more. So in case, if you look at it, you have more than 200 tables to define just 7 things: artist, album, music, and some social kind of collaborative tools. Lot of information to deal with. How we can do better with an NoSQL engine? And keep in mind that when I'm talking about this, I'm talking always in the context of the Hadoop ecosystem. I don't want to talk about other NoSQL database. You have many of them. So if you look at the artist, you have the artist that has multiple alias, and the alias we have specific types, and you have specific type, gender, some information about keys, or at least unique numbers for the database. So if you want to do that in NoSQL, you can do that almost in one single table. But you have to think carefully about how do you want to organize the information. If I go back here, what you have kind of this master table, if I want, with many foreign keys. And the foreign keys, in some time depending, will have a list of value. So what you will try to do, you denormalize the table by bringing into the main table the sub-document or the sub-keys and so on. So what that means, for example, is you will have one many relation inside a single row to make it a lot easier to organize the information, to access the information. So this will be for the other tables regarding the recordings, the albums, the tracks, and so on. And you can do exactly the same. So we'll use for a specific release of an album, what will be the way you organize the information with the list on specific format and so on in one single same table. So we move for this artist and release or recording from 27 to 4. Obviously, you will have to organize a schema depending on your need, but this simplifies a lot the application, the storage, the management, but also the scalability. We don't have foreign key anymore. We don't have multiple transactions to update a specific artist. You do that in a single atomic update. So we can do, obviously, or we will have to continue to do the work and trying to take external table into one single. Tags and weighting could be tables, could be properties into the main rows and so on. So you get kind of how we can organize the thing. If you look at the way in a very simplistic way into HBase, it will be, I create 2 different column family, default and list, for example, and I will use specific field to store the begin date, end date, name, and so on, and the key being Nirvana, and the list of albums. In this case, I choose to use a list of albums and JSON document. I will show you how you can use this into an application, at least for the analytic part. Remember that inside HBase and MapRDB, all these values are simple bytes, no type. The application will know the type. So what is interesting about the NoSQL data model, NoSQL, is flexibility and scalability. But you have something that is interesting with document database. Is in one case, using HBase, it's very scalable. It's very fast read and write. But it's more complex to use than document and simple JSON document. So what we have worked on, and I hope that many other open source projects will do the same, is kind of mixing the two technology and the two approach. In addition to support for the HBase API, what MapR has done is we use JSON-DB. And I will give you an example why we think it's important to use JSON as a database into the Hadoop ecosystem. And for this, we have created MapRDB JSON, but OHI as an API to access this information. OHI being a Java open source API for JSON on Hadoop. So I guess everybody knows about JSON, but just in case, and this is important, especially if you compare with HBase, is it supports data type. It supports complex data structures. So data structures are part of the native integration of a specific view on a row on a document. And it's accessible by all languages. And all the languages to do knows how to deal with JSON. And it's very easy to evolve. And it's very easy to design the applications and update it later on. And if from a JSON point of view, from a document, you have specific attributes, that will be the equivalent of your field or your attributes into into a HBase row, and you have field value, but with a type. And which type of application you want to use and you want to build, I will say that for a wide column, event logging, so what will be all the logs, the time series, and so on, it's perfect. But if you want to use other, more richer design, typically what I said with a music database, it could be easier with a JSON-oriented database. So let's look at these product catalog stories and why it's interesting. So if you build a music store or a bicycle store, you have many products. If you look at the way the products are built, a bike on the page is described exactly like a tire or like a pump. But internally, you agree that they don't have the same field. When they want to kind of work with this in the relational world, I don't know if you know Magento. Magento is an open source e-commerce platform. To get one single product, you have to do this kind of queries. You usually don't do it, okay? Somebody is doing it for you. But the database has to respond to that because you have this entity value attribute where, because you don't know the list of attributes, because you don't know the ways you can organize the content, you have to have this flexible way of doing it. Doing exactly the same with a document store, you just need to store the information you want, and you do a find, or get, or whatever. You can store that on a file system, or you store that into a database. And the reason why it's interesting, it's because you have the same flexibility that I described using HBase columns. You can have a mix of columns depending on your business need for each row. For example, we see 3 products. One is a bike, the first one with size of the wheel, some information of the frame set, group set. The other one are pedals, and the other one is a jersey. All are product, so the top 3 or 6 attributes are the same for everybody. This is the price, the brand, the name, and so on. But the features or the descriptions of the product will change a lot. Think about many use cases where you will have this. Time series with devices, product catalog, contract, and so on. 360-degree views of a customer can be represented this way. So what is really nice, it's very easy to have the backend, the data store, that will really match what you have inside your application. Because at the end, on the web page, what you want to see is this. So you just get access to it using a REST API at the top of OI or this kind of stuff. But also, if you want to make the schema, an evolution of the schema, no need to change the database. It's exactly like in HBase. You can add new attributes. You can add new field. Just save them, and it's done. And this is a very interesting part, and I hope that other people in the open source community will adopt inside at the top of HBase, inside HBase, this kind of thing if needed. So the JSON document makes the data modeling very easy. If I go back to my example of an artist, I took exactly the same data as before. This is what we see. I do a find into MapR DB of the key Nirvana. I get this information. And remember, it was stored this way. Except that inside your application, all these values are bytes that you have to convert all the time, where here, a user will immediately see, and you will have the data type coming from the database. So in this case, I only have strings on Boolean, but you have integer on more and float, depending on how you want to organize the information. So How does it work? Just to, because maybe we'll give some ideas about how you can implement that at the top of another runtime, is MapR JSON DB is using exactly the same aspect of MapR DB. MapR DB, as I said, is using the HBase API, the HBase storage, but instead of using with columns and column families, but instead of using Java and HDFS, it's written in C. And what we have done with MapRDB JSON is to keep the concept of column family. Column family are very important in terms of organization of the data physically in your servers. For example, I will just jump quickly here, or here it's the same. Suppose you have a list here of all the clicks on this specific album. These clicks will grow because you have many users. If you want to keep that in a single document, you don't necessarily want every time you look for this information to load out of the disk for the all clicks. So you will organize that in different column family. It's the same reason you will organize a column family on HBase. But we don't show that. It's for us. The column family should not be driven by the developer. It should be driven by the kind of the DBA of the system, where here you see the column family default on list depending on the data. So you have the capability of using the column family to make it more efficient in terms of IOs. And like in MapRDB, you have access, in MapRDB JSON have security access. You can define on specific tables, on specific columns, who can see or does not see or cannot update a specific field. Quite important when you do aggregation of many data. But one of the challenges of many JSON database is you want to be very efficient and scalable. You want the same performance and scalability that you have in HBase. So this is why we don't store internally the data as a JSON string. We store them as byte. But instead of using very generic bytes that you have into HBase, we keep the type. So we have specific metadata around the row to organize this is a specific column family, this specific field of this specific type, it starts at this specific location, and so on, to make it very efficient to read. And the API that you use when you want to build an application is OHI. OHI is a Java open source project that we have used to build this, but it could be used to access HDFS, MapRFS, JSON document in an efficient way if you want to load data and parse data. And we are working with other people of the community to integrate that to Spark and so on. It's integrated to MapReduce today. And the reason why developers love JSON, especially me coming from Couchbase and MongoDB, when I have to use a pure HBase API, for me it's painful. I don't know for you, but for me it's painful. What I want is the efficient on the performance of HBase, but the easiness of JSON DB. So you deal directly with your business objects, no complex conversion. You can really easily add, remove field, update values, increments, and so on. And you can do that in an efficient way because it's typed. And it's very nice because you can quickly build your first version of the product and just iterate on the schema. Once again, for the same reason as HBase. But you can do that step by step. You want to add one or two fields, it's done. You put that in production. You are not happy with that, just remove that from your code. You don't necessarily have to remove everything from your database. If you only have 3 rows on 1 billion that have 3 fields that are not used, who cares? If it's really important because it's a huge field, you will run a job to remove it. And you can reorganize and organize the content using column families for performance reasons. And for me, one of the key parts, it's very expressive. It's very easy to understand. It's very easy when you look at the row, you understand exactly what's happening inside the application. More efficient in this case than the relational database, and as part of the expressions is human readable, you understand. And how do you access that in your application? One side will be the OHI API, like you have an HBase API. The other side is how do you do analytics? A big part of the analytics today is about SQL. And the Apache project, Apache Drill, is a SQL on kind of everything. Obviously, you can query Parquet, CSV, TSV, JSON file, but you can also, with Drill, in addition to MongoDB, Cassandra on search engine, you can query HBase and MapRDB binary. But because we only have bytes, I'm using the sample that I have showed you. So I go to the artist table, and because everything is bytes, I have to transform that into a string or into what I want to deal with. For example, I convert from the list of album, I convert it to a string using UTF-8, and I convert it to a JSON object, because this is a JSON object on which I will be able with drill to access any information. So even if you have complex data structure into your HBase or into your MapRDB JSON, you will be able to use a select statement to do the analytic. Except that if you use a JSON, it's just easier to deal with, because JSON is part of the drill format that you can work with. So just in a generic way, I want to basic tips at the end based on the schema. So first of all, I should add that in big. It's very hard to know if you have a good or a bad schema. The most important part is, does your application work in an efficient way? You focus on your application use case. So one way of thinking about it is, when you design your applications, you design about the question you will ask. You do aggregations, you do processing, not necessarily only the response that you will send, the answer you will send. And for scalability and access, especially because today HBase and MapRDB, they don't have secondary index, native secondary index. You have third party where you can synchronize with Elastic or Solar to simulate secondary index. So if you want a very, very efficient way to access the information for doing updates, deletes, or find, or scan, you have to really organize the row keys and the keys of your columns and your attributes carefully for access and for distribution of the data on your cluster. So if you have to write a lot, think about trying to distribute the write. If you have to scan, try to make all the scan on the same machine to make it more efficient. But obviously, these two rules are kind of antagonists, so you have to think more about it in real life. And sometimes we have discussion about the lack of transaction, multi-rows transaction. Keep in mind that on a single row, the updates are done atomically. If you do an update on multiple fields, on single row, it will either succeed or fail. Exactly when you do an update on multiple tables in a commit, on a rollback on a relational database. Think about that, because in many cases, if you look at the way you create an artist in a relational database, you will create the artist, some information about the alias, and you want that to be transactional, because this operation has to be transactional. The reason why you need transaction in the relational database in many, many cases is because one single business object touches multiple tables. With the design that I showed you, especially on the music brain and product catalog, you are modifying one single document or one single row into HBase. This is atomic. If you design it correctly, you will have the same level of business transaction with a single transaction on a row. And also, use a lot pre-aggregation. When you know that you have to calculate many things, and this is probably what you do today in the way you use HBase into your project. You will have the raw data on the file system, and you run some jobs to do aggregations, and the result of this aggregation will be stored and updated in HBase. Think about the same thing when you build interactive application on the NoSQL database. Try to avoid too many queries to do scan and so on. When you know that a specific subset of the document a subset of your database will never change, just do the calculation and it's done. You save this calculation. Then you have only few rows or documents or few rows or record to read to calculate and get the information. Thank you. So if you have any questions. Yeah. I will just, if you don't mind, because it's recorded, it's just for.
What about some advanced analytical questions? Like if you think in terms of MDX or DAX calculations, how would you do that with NoSQL? So comparing, I don't know, an average value in your example of sensors, sensors, average value for the last 1 hour to the first value of the day, for example, for a specific sensor.
So you can do that with SQL with drill, for example. Okay. You will have one way of doing that, or you use Spark to do this kind of job. The database itself, they don't have any processing power. And we think that it's a bad idea to put too many processing power inside, because this is the best way to slow down your application globally, separate the processing from the database itself. Was there a question? Yeah. So I will just jump to. Yeah.
My question is about data redundancy. In relational databases, the normalization actually avoids duplication of data. So in our case, 2 artists can be assigned to a single album. If we want to rename the album or modify the album, how we can handle this case? Because we need to search actually where this album is assigned. So, and also I have another question, sorry. About security.
So I will answer for this. So yes, you duplicate the information a lot. And really based on your application, if you know that this specific value will change all the time, you will kind of either stay in relational, if you can, or create a kind of a relation between, a reference between 2 tables. But most of the time, you will see that this duplication, you can do lazy update. You have the master tables that will, when you get the album, you know that it has changed, for example, on the timestamp, send an update differently.
I guess the answer is the same about the security. If you want to restrict security to certain columns or properties, then we need to split to separate.
No. Into MapRDB. I'm not sure about HBase, but into MapRDB, with the HBase API or MapRDB JSON, you can put security on field. You can say this specific.
JSON?
No, even on MapRDB HBase. On the pure HBase, I don't know. I hope that it is. Because everybody, when people are using MapRDB, they are using when using MapR, they use MapRDB. It's just the same API, so it doesn't change. Yeah? So the question is where MapR fits in all this kind of stuff. I don't need to make. MapR is, let's say, so it's just, we change the persistent store. Everything at the top is the same. We just replace HDFS by MapRFS to have a short answer. And we can discuss just after you come to our booth to see more about the architecture.